Let's go over section 2.4. I want to graph the linear function f of x equals 1/4 x minus 3 and identify if it's a constant function or not. Give the domain and range. Let's find the slope. Recall f of x equals mx plus b. The m tells me the slope. In our case, m is the number in front of the x, or 1/4. The b is going to tell us the y-intercept. Now this is a -3. The y-intercept is a point, so write it as 0, -3. Don't just say the y-intercept is -3. Make sure it's stated as a point. Now we can graph the y-intercept first. 0, -3 is here. And then I'll use the slope. The slope represents the rise and the run. The rise is going to tell us we need to go up 1. And the run is 4, so we'll go to the right 4 from there. We'll start at the y-intercept, 0, -3, go up 1, and to the right 4. 1, 2, 3, 4. And all we have to do now is connect these 2 points, and here is our line. Now, what's the domain of this line, and what's the range of this line? Well, you can see it goes to the left forever. It goes to the right forever. This thing goes down forever. This has a slight angle down, and it also goes up forever. So the domain and range is the same, -infinity to infinity. Question 2. Again, we're going to graph using the slope. F of x is equal to -4x plus 0. There is an invisible plus 0 at the back here. So we know m equals -4. Or I could rewrite it as -4/1. So this is my rise, and the 1 is the run. Now this 0, it was invisible, but we put it there to remind us the y-intercept is at 0, 0. That's the origin. We will plot the origin first, and then we're going to use the rise. It says a rise of -4. Which means we drop down 4 from the origin. 1, 2, 3, 4. And I'm going to go to the right one. And this is our graph. The domain and range for this line is -infinity to infinity because it goes to the left forever. It goes to the right forever. That's why the domain is -infinity to infinity. Same thing for the range. It goes down forever. It goes up forever. The range is -infinity to infinity. In question 3, let's graph the line -2x plus 3y equals 6. And again, state the domain and range. Now for this problem, it's not written in y equals mx plus b form, so let's rewrite it so it's in this form. The first step for this question is to subtract or add 2x to both sides. Let's add 2x to both sides. I have 3y equals 2x plus 6. Now it's getting close to this form, we just need the y by itself. Let's divide everything by 3. We have y equals 2/3 x plus 2. Now I can breathe off the slope. The slope is 2/3, and the y-intercept is 0, 2. Again, the slope is the number in front of the x, and this 2 tells us the y-intercept. Start by plotting the y-intercept first, and then using the slope. The 2 is our rise, so we'll go up 2, and the 3 is our run. We'll go to the right 3. And here is our graph. The domain and range is going to be the same. It's negative infinity to infinity and negative infinity to infinity for the range. Question 4, let's use the slope formula to find the slope of the line that passes through the given points. Recall the slope formula, m equals y2 minus y1 divided by x2 minus x1. Always start by labeling the points. Let's say this is x1, y1, and let's say this is x2, y2. This means I can plug it into my formula. We have 4 minus 2 divided by 7 minus 5. The top becomes 4 minus 2, or just 2, and the bottom is 7 minus 5, which is 2. 2 over 2 simplifies to a slope of 1. So between 5, 2 and 7, 4, we have the slope is 1. Question 5. The manager of a small company that produces roof tile has determined that the total cost in dollars C of X of producing X units of tile is given by C of X equals 200X plus 1,000. While the revenue in dollars R of X from the sales of X units of tile is given by R of X equals 240X, find the break-even point and the cost and revenue at the break-even point. For this question, we want to ensure that the revenue is greater than or equal to the cost function. We have the revenue function is equal to 240x, and that's supposed to be greater than or equal to the cost function, which is 200x plus 1,000. Now let's subtract 200x to both sides. We have 40x is greater than or equal to 1,000. Let's divide both sides by 40, and x is greater than or equal to 25. So we have to sell at least 25 units. This means we have to sell at least 25 units of tiles in order to break even. Now, if we want to find the revenue where we are producing 25 tiles, we can plug it into the function. 240 times 25 is our revenue function. What is 240 times 25? We get a total revenue of $6,000. Or we can plug in the 25 into the cost function, and we have C of 25 equals 200 times 25 plus 1,000. And you will see this is equal to $6,000, which makes sense because our revenue function is equal to our cost function because this is the break-even point.